Okay, first examination and impression of this MC2505 I just bought. Took off the bottom, a few screws are missing. Looks awfully dusty and a bit rusty. There's like a layer of, the paint kind of lifting up. Looking inside, you got a nice little spider and some general cobwebs, but you know what? Everything looks original. I don't see any part that's been replaced based on that little experience I have with the 2105. Now, except that they've taken the wires off the terminal blocks and wired them to those outside connectors, right? So the terminal blocks are ruined, but other than that, it's all original. Let's take a look at the top. Removing the meter cover. This may have had some printing on it. It kind of looks like this has been repainted. I'm not sure, but on my 2105 there was a lot of text there. Again, just dust, some cobwebs, and a very old looking meter board here. But again, I'm sure that's all original. We've got all the light bulbs installed, and these caps look original. Yeah, kind of all untouched. Just the outside is very, very weathered. Okay folks, I got this amp a few weeks ago. Mcintosh MC2505. I think it's from 1974. And I was so overwhelmed by how horrible it looked. I just did a few clips there, but I didn't really explain the story of this amp. So about a year and a half ago, I got an MC2105. If you look through my previous videos, you'll see a refurbishment of that. So I learned everything about that 2105, and I got a little bit of a confidence in working on these amps. So a guy messaged me through social media that he had one of these, and I bought it from him as a little project to start off the year. And obviously it's in way worse condition than the 2105 that I got. When I bought the 2105, I was kind of scared. I was like, well, if anything is wrong with this amp, I don't know how I'm going to deal with it. But everything just sprung to life so easily that I had some more confidence in this one, despite the way it looks. So I've been doing some cleaning up, believe it or not, getting off dust and so on. And I'm just going to point out the big problems with this. The first big problem is that a previous owner just absolutely ruined the faceplate. Maybe it was bubbling or whatever, but the lettering would have been on this side. This side has the paint and lettering, and they scraped off all of the paint and text and so on. You can see there's even some cracks, and they put bomb spray, like rattle can spray on the front. So this is just a wreck, right? And but they had everything else was present, all the knobs and so on. The other thing is that the caps were completely rotten, leaking all over the place. I don't think I still have them. I think I might have thrown them away already. And the other thing is that there's a lot of rust. Okay, some chrome left under the footprint of that cap, but really everything is kind of rusted. I've been going over it because obviously some previous owner, whoever painted the faceplate, also put paint on the chassis. So I've been trying to get that off, but in getting off the paint, I mean, the rust below it is not any prettier, right? Besides, I've been trying to clean all the surfaces. I am sure everything has been painted. These have a layer of paint on them as well. Okay, so that's the problem. A lot of cosmetic issues. As I showed before, the speaker terminals are messed up, but I have new ones on the way. I have a whole capacitor set on the way and all the obvious stuff. One other thing bothering me too is there's so much cosmetic issues. If you look at this, these look mismatched. I wonder if one was replaced over the years, because I haven't seen pictures with these mismatched, but this is kind of pitted on the white paint, and this is not pitted as much, but it's kind of brown looking. So again, this is, even if I spend a lot of money on the new faceplate and all the electrical work I'm doing, it's still gonna look kind of grungy, you know. So I'm kind of tempering my expectations of the outcome. Let's look a little further into the actual workings of it. Okay, so having had this for the last 3 weeks or so, of course, and having some experience from the last amp, I've been going online and learning a lot about this amp. There's a lot of actually everything is different about this and the 2105 100-watt version. There's no part on this that is used on the other 2105 model. I don't think anything is interchangeable. Maybe the meters and the front, I don't think anything is interchangeable. Maybe the meter switch, speaker switch, power switch. Everything else is different. Maybe the terminals are the same. And these, some jacks, but piles of differences. And the layout is different, the circuit is different, everything is different. But I'm learning. So I've done some cleaning up, and I'm starting to form in my mind a list of things to do, right? For example, I looked at all these output transistors here, and some of them appear original with the Motorola logos on them, right? But some of them clearly have been replaced, right? And corresponding resistors on them have been replaced. And on the inside, the power resistors, like the emitter and bias resistors, I might even be using the wrong terms, are clearly been changed and even have the wrong values. So part of my summary is to change all output transistors. I've ordered all replacements. So anyway, let's look at this list. Clean up, dust, getting out the spiders and basic layer of crud on it. Looking how much rust is there, how much rust can I take off, and how much I actually have to live with. Paint, how much paint I have to remove all over here, and can I repaint certain parts nicely, like the covers for hair, and there's a cage that goes over this I can repaint nicely. But again, how much of that is going to make sense if half of it looks nice and freshly painted and half of it looks old and cruddy? Okay, so I have a lot to consider about what I can undo and redo nicely, right? And on the inside now, the circuit itself, the electrolytic capacitors, I'm changing all. The main big ones were so bad they were actually leaking fluid, and I wouldn't even dare to turn this on with the condition those were in. So a standard thing for me is to change all electrolytics. Now looking through at the amp, an amp this age, this one seems to be from 1974, according to some of the date codes on the ports. These model amps all use carbon comp resistors, which are the standard technology of their day. Now, these things don't age well, right? This amp is 50 years old, and as you can see, it's been in a horribly dusty and humid environment, as with all the rust. I mean, there's rust inside here, you know. So I don't have much faith or trust in these resistors. I've been measuring them. A lot of them are just at or outside of a 20% spec drift, outside of the 20% tolerance. And these resistors are really supposed to be within 10%. So they're really, I think, very few of them are actually in spec. Some are, but not many. Okay? And again, comparing to the 2105 I worked on before, those resistors had a little bit of drifting here and there, but there was a lot of consistency from one channel to the next, left to right. And when I finally fired up that amp, everything worked perfectly, very good, strong output, crystal clear sound, right? So I had no reason to think that I need to change those resistors. With these, I don't trust these resistors in here. I want to change, I think I want to change all, right? Because of the humidity that this has been exposed to. So resistors, I think I'm changing all of these big power resistors here. Half of these are completely wrong values, right? I want to change all of the carbon comps, and even the big ones in the power supply. These are 2-watt carbon comps. These are all drifted way off in value. Like if it's supposed to be 220, it's probably 270, that kind of thing. They're all way off. So I'm going to change these with metal films, and I've ordered a whole pile of carbon films to replace all of these. Now, carbon film is just the next technological step up from the carbon composition. And if there's a tonal consideration in the type of resistors being used, carbon film would be an appropriate substitute for the carbon composition. Yeah, you could get into metal film, but some people actually say those can have a harsh sound. I don't like commenting on that stuff too much, but I'm not sticking with the original type. These are hard to get nowadays. They are expensive. And these use a lot of low odd values like 18 ohms and 22 ohms. Then, I'm not even finding those values in my regular suppliers of carbon composite. Looking for modifications, there were a few wrong values in these big cement resistors, and there's some output devices on heat sinks have been changed. So I'm gonna undo those, put back the originals or the current, the most suitably available correct type to use, because the originals are actually completely obsolete, right? Repairs, I haven't really found any disasters. I haven't seen anything that's burnt or busted up. Everything is, it's kind of ratty looking, but everything's intact. All the diodes are perfect. They read correctly. The capacitors are all changing. I'm gonna be doing, but having said that, everything is nothing is really damaged except where they messed up the terminals. The issue of transistors, there are a number of transistors on this input board, on the output boards, on the heat sinks outside, and up top on the other side there's the meter board. I have a bunch of small and large transistors, and I have ordered replacements for all of those. Now, back in the 2105, even though that amp was in much better condition, I ended up reading funny voltages on all the transistors legs, and I did change all of those. So I'm going to do the same thing here. Speaker terminals, I've ordered some new ones for this. They're type called Cinch Jones, and they appear to be the 140 series, which is a 3/8 of an inch spacing between the terminals, right? So those are on order, right? Okay, so the cosmetics issue on this is the main concern. It's the main thing holding this amp back from being restored perfectly, because I can't undo this rust unless I find a new chassis with very good chrome on it. I'm stuck with this rust, right? And then the discolored meters in the front and so on. So I'm kind of holding back my expectations of how nice I can make this amp look when I'm done. I'm hesitant of how much money and effort to put in, right? It's like I can clean the chrome, but only up to a certain point. I can't re-chrome it. I could kind of try, but it's really I've been told that the local rechromers are no good. Repainting, maybe I could repaint the transformers. I can repaint the back covers. There's a long top cover and there's a cage perforated cover I can repaint and make look nice. Maybe I'll paint the transformers as well, right? The front glass is a big issue. Now I am actually playing with the idea of making a faceplate out of plexiglass and engraving it myself on my new CNC machine. So I've actually been drawing a new faceplate. But other than that, I would have to replace the faceplate with an original glass one, which could cost quite a couple $100. Like I think it'll cost upward of $200 US, which you know, I don't know if you want to spend all that money on an amp that looks so ratty in every other way. So again, I'm not sure which will go. I like the idea of making the plexiglass one just as an exercise, and it might come out nice. But who knows? If the amp works really nice and sounds really good and everything tests perfectly, maybe I'll treat it to new glass for the front. Right, so the last thing I'll have to do, not necessarily in this order, I'll probably do this before the cosmetics, but testing and finishing up, because I'm concerned to get the output devices right, all of these here. I'm concerned. I'm sure that I've repurchased the correct ones, and some of these may be original and may be working okay, but I'm keen to get that right. So I will be changing those output devices, and we'll be looking to get upwards of 50 watts per channel. I've read over and over that these amps can go as high as 70 watts per channel, right? And I sure hope that these transformers are in good enough condition that it will actually give me that kind of extra performance. You know, that'll be a great thing. Okay, so getting down to it a bit, I've been trying to just get some rust off of this chassis, starting with the paint that's sitting on it. And you guys, everyone would cringe if they saw what I've been doing, but I've been using this kind of heavy steel scrubbing pad and Dremel wire wheels, and even scraping with the tip of a dull chisel just to get the paint and cakes of rust off. And I loosen these heat sinks to do that, because it's very hard to get it in between everything without loosening them. And you know what, I'm actually starting to see some chrome. Obviously at this point I'm not trying to preserve the chrome, but at least if I can get the paint off and knock the rust off, I'll have a pitted surface, but at least it'll be clean. Maybe I can put some wax on it to preserve it, but at least it's not caked with old paint, right? So I'm working on it. And all of that brown haziness around the rust, and chrome, hopefully we could just get it to like a kind of gray look like this. I did it on the back panel first to see where it's not shiny. All the lettering is long gone, but at least it's not a big brown crust anymore. Okay, so more parts have started to trickle in. I bought a general service kit. I bought some new speaker output terminals. Not everything has arrived. I'm awaiting a lot of resistors and diodes still. These are the big capacitors that go here. I didn't buy the right, you know, it's kind of hard to find these in the right height. And I actually consciously bought ones that are a little taller, because I never planned to do a wooden case for this. It's not my kind of style for this. Anyway, so with some parts coming, I'm getting a little more confidence to break things down. I have loosened all these heat sinks. I started to understand the mounting of the output transistors and so on. This is the first time I'm ever dealing with this stuff. Anyway, let's take a look. Both of these look to be replaced. You even see like there's wrong screws. Whoever changed them didn't have the courtesy to put back the original screws right, and these two look replaced. Some of these look too greasy and stinky to return to service without cleaning. So what I'm going to do is I'm going to take off these heat sinks, which is going to give me the opportunity to mount the new ones, put new resistors in the sockets, and while these are off, I can scrub the chassis around there a bit more. I think that's a good move. Okay, so I'm doing some stripping down, and like everything else on this amp, I mean, the old parts really do have a lot of wear and tear. So like that was replaced at some point. That's a 47 ohm, and it measures correct. That's been replaced. But this one, this old original one, which is a 10 ohm, is reading over 12 plus. This original looking 47 here is reading 59 ohms. So again, way out of spec. So all the resistors in this amp, every one of them I think is going to get changed. Okay, haven't taken off those transistors. They're still wet. I did some simple green soaking and scrubbing of all the heat sinks, right? Just take off all that grease and stuff. And I also went over the chassis. Now again, the chrome is kind of gone and there's a lot of rust, but I've managed to remove a lot of the appearance of the rust. In other words, by scraping off the dusty part of the rust, it's a lot of pitting, but at least the whole surface doesn't look as brown as before. So, you know, it's more of just a shitty gray, right? What I'm going to do too, I'm going to do the trick where people rub aluminum foil on the pitted surface. I noticed that that trick doesn't really clean the metal, but it kind of leaves, you know, it smears aluminum onto the steel and leaves the appearance a bit more silvery gray. Feeling very lazy about removing and painting these transformers. Feeling very lazy about that. But still some chance I might do it. Regarding the output transistors that I broke down, I may have mentioned earlier in the video that these were somewhat original, but I don't think they are. Like these, I believe are correct replacements. That 15024, that's a correct replacement, but I don't think that's the original item, right? So as I'm just learning about these output transistors, you can spend a whole lot of time online trying to cross-reference the more modern substitutes, right? And I have to say, I find that anytime I ask or read about these things on online forums, people are not really very helpful. They seem out of patience with people like me asking these questions for the first time. And they say, well, there's a million threads about that. But there's no information. There's nowhere online that I found, okay, here is a list of replacement modern transistors for MC2505. That doesn't exist anywhere. There's just a million threads scattered around the internet with partial information and some struggle to keep up with modern stuff versus obsolete parts. It's really not that much information around. That's why I ended up buying a kit for this, because it just had a bunch of transistors to put in. And I'm like, well, cool, I'm not going to argue. I don't need to cross-reference a million things from people who are not so helpful. Right, so I do have new ones. We'll get to that a little later on in the assembly phase. All right, so a quick look at this thing we've read about here and there. I think the aluminum I mean, I've seen videos of this on YouTube. It's people use to clean, you know, chrome bumpers and stuff, and some of them it looks really miraculous. But to me, for what I've used it for so far, sorry for the camera jiggling around, it tends to smear some aluminum residue onto the rust, onto the brown spot, and kind of lightens, evens up. Look, it looks good actually, but it's, you know, it doesn't make the brown part completely silvery. What else? And yes, of course, the hard surface of the aluminum would burnish away any rust, dust, crust. So I'll rub it a bit and just try to get it look as good as I can. Well, now that's actually kind of impressive. Well, all right, the pitting is all still there, but the color is so much lighter now. rubbing this thing again. Lots of aluminum residue. Now, I think if you do something like this, if you're just looking to clean it, you do this rubbing with water or WD-40 or something. But if you want to get that cosmetic look, where you're just trying to make it look less brown, don't use any liquid. Like, all right, look at this finger here. Here's what's really going on, right? It's leaving a silvery residue. So don't be too fooled by this. Okay, as I said before, the chassis looking a little more presentable despite losing all the lettering. The chassis being more presentable edges me closer to refinishing the transformers, even though I'm being very lazy about removing them. So I kind of, right, so I build guitars, amplifiers, I do a lot of DIY stuff, so I have all kinds of paints hanging around here. My automotive black paint and my rattle can sprays are too flat for this. I need something a little shiny. I'm trying something new, so I just took a lacquer that I have, this semi-gloss, and I added a dye to it. I'm often mixing my own colors, like when I'm doing like a Les Paul style finish and I'm doing a sunburst and stuff, I'm always mixing dyes and colors. So anyway, I've colored this semi-gloss lacquer polyurethane, and I put it on the back of this steel serving tray overnight to see what sort of a sheen I get. I just kind of painted this on with a brush. You can see little dots of dust on it, but I think the sheen looks about right for this job. Not too shiny. A little bit of a satin look, right? And I'm going to be spraying this on. So this, the way I put this on last night, it kind of leveled itself off. I think I'm pretty happy with how that looks. And that's a hard, very cured finish there. As well as the bottom tray, right? All of those things need to get painted, not just the dumb transformers. Okay, I spent a little time doing some sanding of these metal panels. I didn't go all the way through the paint down to bare metal. I just tried to make, I really spent some time on this. The paint, original paint, is really, really tough. But really I just want to get off the rust and smooth the surface, right? Not trying to make it look new. Some of the painted over warning signs and model numbers kind of emerged when I sanded off the overcoat, and the model number and logo and stuff came up here, but it's pretty much gone. I've masked it off to preserve what's left, but I didn't get to preserve that intact, right? The other caution, electric hazard warning. So I'm going to spray some black on this now. If this comes out real nice, I'll know how I'm dealing with the transformers. But this is, I'm definitely going to paint these, but I hope that my mixture of paint and methods and sanding and all that gives a good result. Okay, so I've been experimentally painting the larger black panels on this. I'm not happy. The pitting that was on the surface is showing through. You see, like there? Because I'm just not really able to sand down through the pitting. This is sheet metal. I just can't really do it, right? And the thing is, because it's a gloss, semi-gloss kind of surface here, gloss really shows up flaws in the surface. So these are really just some quick initial color coats, but I'm not happy with it. I think I'm going to have to move over to more of a flat finish, like that. That's an experimental piece of the flat sheen to get along, because the pitting is just too much, really. So I'm going to have to shift over to a flatter sheen for these. And over here, what's worrying me even more is doing the transformers themselves. I've taped off the labels, and I figured I could get away with just spraying the outside without having to remove them and unwire everything. So I've been sanding around the sides, but again, there's pitting in it I just can't sand through. So it's going to get nice flat finish rather than semi-gloss. Okay, so I've done my best here layering up a really heavy coat of black, and I'm hoping that kind of sits up. You can see it's kind of lumpy looking on top because of all the pitting again, and hopefully that dries neatly, and we'll put flat on top of that for it's probably the best result. Okay, so this is dry now, and again we see pitting in the dried surface. So maybe if I just keep adding more lacquer when it's sitting in this horizontal position, it would kind of fill in and level off, hopefully. I'm not sure, but thing is, it looks better than before. Okay, and it's more sealed up and protected, so it's not looking new, but it is an improvement. Let's peel this away right now, because after this I'm only adding clear coats over this, so this masking is no longer necessary. I could touch up the black on the labeling a bit, right? As I say, fix that up a bit, but yeah, I could fill in these little dots. Better than before, better than before. So you see now, that's not looking bad. I took a little like a black paint pen and silver paint pen and kind of filled in and fixed all the little scratchy parts of the labels. Okay, here you can see what I'm trying to do. I've just sprayed a really heavy semi-gloss coat on the top of the transformers, and the idea is that it would level off and try to hopefully fill in and give more of a level surface, right, than before. There's a bit of a blue tint to it, you can see. That's because this is water-based polyurethane, that set of coats I just sprayed. And I never knew that water-based polyurethane was good for anything other than some woodwork, but apparently it gets high praise online for like metal, clinging to metal surfaces. So I think so that's what I actually used to mix the black, and I'm now onto the clear part of it. Okay, so having done numerous coats of semi-gloss and gloss and built up the finish a bit and sanded it flat, I finally did a final pass of the satin sheen today, and I think I'm happy with that. I mean, if we do a quick before and after, right, there's just an immense improvement. Okay, I did any bottom pages. I managed to save these, which were covered in black paint from the previous owner, and these came back fine after a little bit of sanding. And this too, but it didn't really survive. I left this text here. I taped it off and did black and around it, but I lost the model number there. Anyway, still a huge improvement here. Okay, so I've left the lacquer on this to cure up and dry for a couple of days. So I think it's time for us to move along to the next phase of the project. I get to peel off this masking, and again, I've done this the lazy way, and I'm sure there's a little bit of overspray here I need to clean off, but it's just easy to do and doesn't really matter because the lettering's dead anyway. But you can have a look now. I could kind of flash up a before and after picture of how this was looking prior to the rust removal and transformer paint. Again, there's no miracles here. We're just cleaning off the damn dirt. So that's looking a lot better. Okay, so we're back into the workshop, onto the workbench, and we're done with the transformer painting phase. I'm now feeling to start doing the work and putting in new parts. I'm still waiting on my diodes, but I have everything else I need. And I'm gonna start thinking about how I'm gonna change the capacitor setup there. And basically I'm ready to start reassembling. I think I'm going to make a list and show you now what I plan to do going forward. Okay, so this is the first list that I wrote out, and I've done this part. Okay, and then this now evaluating, I think I'm not going to bother with this too much. I'm going to skip to this. So that is leading me to this list of the details of how I should deal with the different components. I'm going to start by putting on the big transistors. I got the old stock Motorola's and the heat sinks hanging around here to go back on. Power supply capacitors, those are the big ones, and the smaller ones that live in these multi-cans. I need to figure out how I'm doing that arrangement. And then a three-prong power cable conversion, right? Because here we still have our original two-prong, but I do not keep two prongs. Okay, at that point we could power this up and do a voltage test. We could check that all of the different voltage feeds for the preamp, emitter section, and driver section are all kind of what they should be, and make sure that the power transformer is putting out the right voltages and so on. We could test that at this point, right? And then, as I said, I'm kind of committed to changing all these carbon comp resistors as well as the big cement resistors to new ones, right? And we're changing to carbon film resistors. And then also the signal caps. We change like the colorful tropical fish ones, which people usually replace. And then the small NPN and PNP transistors. There's quite a number of them, and I don't think I trust any of them at this age. And then we could mess around when it's all running with the power testing and meter calibration and so on. So let's get into it. Okay, so these are all Motorola devices, which are a nice way to start things off. The original model number devices are all obsolete. So these are either the next generation that are available or the current generation that are available. But these are all the correct, most appropriate replacements. Now, some of my originals here may be working okay, but again, I wanted to start fresh with everything. Like this, they're not exactly the same, but the one on the these are both the 24 and the 03 are both appropriate replacements. But anyway, we're starting fresh. Okay, so I've decided to start with tackling these driver boards. They're really filthy. They were sitting sideways. I think they got a lot of dust through the vents and heat sinks into the chassis, and you can see even these have been kind of cleaned up, but you can see how much grime and dust is kind of stuck on it. Plus all of these old resistors, which are mostly out of spec. So here I've taken off most of those resistors and put some rubbing alcohol with a toothbrush. Just try to clean the surface as best as I can. I don't think it's going to look new, but it's just getting off surface grime, right? I measured these resistors here, which are originals, and they are the 1% precision resistors, and they measure very much on target, so I'm tempted to leave those there. They read so well. I'm still waiting on a few diodes. I'd like to strip the board entirely, but I am leaving these wires mostly on for now, so I know what's going on. I'm going to restuff this board before I break this down. I'm going to keep this intact as a reference for when I restuff this board, right? So I don't get lost or confused when both are stripped down, you know? I've been scrubbing away at these parts, just cleaning them as best I could here. The wires, I haven't really pinched clean on them yet and gotten the grime off. But all right, so these thermocouples have cleaned. These sockets for the large devices. A lot of little wire connections have busted, and I'll restore those when everything's back in place. Okay, so now having cleared up and removed old parts from this board, from the kit that I bought, I've added in resistors that I intend to change. Now these are the carbon film type rather than the old original carbon composition. Now let's have a quick word of that, because it's always a subject of discussion when restoring old gear and you change resistors and try a new modern type. People make a fuss. They say, oh, that's not the original. You should leave the resistors alone. Mcintosh knew what they were doing. Right, but the fact of the matter is that these are the worst type of resistors that there are. So let's refer to the factory service manual, where all the parts are listed there. They list all the parts except the carbon comp resistors. So we start at the top. All parts not listed, that would be the carbon comp resistors, are common items obtainable from radio parts jobbers. So they haven't specifically said we need that type of resistor to be there. And the fact of the matter is that anything else is an upgrade. So I have not gone to metal films, I have gone to carbon films. Metal films are more modern, more precise, temperature stable, but some people do say that those can impart a harsh sound in an amp, but I'm not getting into that experiment, but I'm using the carbon films. Now in this schematic, there are two resistors on this board that are precision resistors. They are 1%, and they are listed here as 560 ohms, 1%, and there's another one that's 1.8K, 1%, wherever it is, somewhere around here. And it's that one there, that's the 1.8K. So I spotted on the board, I left them in because they're carbon films. This is the type I'm moving to. And when I measure them, 1.81 after 50 years, it's supposed to be 1.8. Okay, and let's measure the other one. The other one is even more accurate. So I'm measuring the other one now, and again, it's supposed to be 1.8, right? 1%. So this is so close to being absolutely accurate, and this is on this is the original resistor on a board that has been in this stink, grimy, dusty, hot, rusty environment for 50 years, and it's still giving a reading like that. Why didn't Mcintosh use this type of resistor in the whole amp? They would have been common and cheap at the time. So all of those who argue in favor of the carbon comps, just imagine what things would be like if they were all these carbon films all these years. So anyway, that justifies my choice to use those same type now going forward. Okay, so I've fully populated these boards, all new parts, and even the resistors that are attached to the output devices. In this case, they're 47 ohm and 10 ohm. And I'm moving on. I can't go any further in this area because I'm missing a few fasteners, some screws and bolts for the heat sinks. Anyway, so I'm gonna just shift my focus up to the power section. We have this bank of resistors that drop voltages to the different power rails. And again, back to this topic, why I'm changing all resistors in this amp. We have, this one is supposed to be 27 ohms and it's reading 32. So again, that percentage is so off. That's, well, just under 20%, 15-20%, is going to throw all of those voltages off in that part of the amp. So again, that's why no old resistors are going to survive this this restoration job. In replacing the power supply voltage rail resistors and diodes, I've done this whole section. Look at the dirt on some of the resistors that came out. I mean, these amps, look at that. These amps have holes in the above certain areas for ventilation, but it's really just been a dust collector for certain items. Okay, I finally have a concept in my mind of what to do for all the new filter capacitors, aside from the major big ones. So there was two can capacitors here that stuck a little bit way through the chassis, and one of them, this one here, dealt with a backwards negative voltage for one of the supply rails, a negative 40, and another one dealt with 4 filtering sections, right? And they kind of suspended in the chassis like this to isolate them from the chassis and also have them at a certain height. But I am not bothering with any of that stuff, right? So I didn't know what I was going to do, but I finally figured I'm going to float a phenolic eyelet board here, which is this thing, and I'm going to stick all of these capacitors through and mount them a certain height and run all of these, the original wires, to that bank of capacitors, right? So I'm going to cut this to the size I want, and you'll see how I'm going to mount it up there to make sense, and it'll be easier to deal with in any future servicing. Okay, so I'm going to take my bandsaw and belt sand. I'm going to cut that rectangle out, and these standoffs here are going to go into 2 original holes from those canned capacitors, and they're going to hold this board up at a particular height and give it all the clearance for these capacitors to live underneath. So the capacitors are going to be hanging down. Cool, so let me do that, and you'll see more and more what I'm getting at. Okay, so I now have this little phenolic board. I'm going to drill 1/8 holes in all the little spots that you see marked off, and then put eyelets in. Right, so here's our little board. Here's the standoffs that give us the right height for the capacitors to live under, but not be so tall that it's sticking out through the chassis, right? The bottom of the chassis. Right, so in my last video I did on my MC2505, there's a section that I did a little board with the same material to replace the canned capacitor in that one. But I used turrets for that because so many wires needed to go to each of those terminals and wrap around them. But in this one, they laid out really differently. And here they go from the power dropping resistors via a wire over to the capacitors. Whereas on the MC2105, there's one capacitor with all of the resistors piled right on and wired right here. So it's laid out much nicer on the 2505. So I'm going to stuff those capacitors in and show you how I'm wiring it up. Okay, so I've arranged these capacitors in a row according to the layouts on the schematic. This is the last version of this amp. This is the latest schematic, which is the was it 36K 100. So going in this order from right to left is actually how these capacitors are going from left to right. So we're doing 100, 100, 50, 150. So these are 100, 100, 50, 150. This last one on the board, take note, need a lot of commentary here. There's the original one, there's this big capacitor originally in the amp that had one section. Now this capacitor has a insulated outer jacket. You can't really see it, but there's a clear plastic jacket on this. And this was insulated from the chassis, and it was wired with the positive terminal going to ground, right? So this center part here was grounded, and this outer casing acted as the capacitor's circuit terminal, right? So because it's doing a negative 40 filter section. Right, now the main note here is that the original drawing on the schematic shows this capacitor wrong. It's normally shown with the plus sign up here, which is backwards. Okay, there's an error in the schematic. This is the error, so I've corrected it. The plus part goes to ground. So in this case, this center terminal went to ground. And in this new board, this negative terminal would be going to the voltage rail, and the positive side here will be going to ground. So this whole row, the upper row, is getting grounded, and the bottom row is the individual voltage rail points, right? But again, this capacitor is reversed, and I've corrected it here. Major point for anyone looking at this thing. Okay, so this is how it's looking now. We've got this mounted up here. It's very sturdy, right? And it goes through and it mounts to the chassis with these same old style hex head bolts. Now later on in the project, I could make some aluminum plates and hide this hole from the inside, but I could do that later on in the project, not right now. But you can see that the capacitors hang down, none of them touch the chassis. There's enough room on top and below. And all of these wires that went to the different capacitor points back when it was the multi-section capacitor, they will just be going over to these 5 eyelets here, the last one being that negative one. Okay, so there is the power supply board as I thought of. We've covered all capacitors. The original wires that went to the multi-can are now snaked up through these holes into their respective capacitor eyelets for the positive ends, and all the grounds are tied together, and that's grounded at the chassis right in the area where the big capacitors are grounded. And that's it. Again, the one on the end is the reverse one. All right, that's the negative 40. There's 2 lines that go from here to the power board. Okay, and they may connect here as well. So I'm on to the next thing. For now, I'm missing some fasteners to mount these back and the heat sinks and so on. I ordered some new fasteners that haven't arrived, so I can move on to the input board or maybe the meter board. Okay, so I've flipped this over top side and stripped out all of the parts except these adjustment wheels, right? Took quite a long time. I curse the person who loaded this board at the factory because they bent all the leads over very, very hard, 90 degrees on this side. So they were really hard to get these old parts off. Right, so now I'm going to refer to the manual here and start restuffing boards and start restuffing all the parts, and they're all gathered in this particular bag here. All right, so I've put everything in, all new parts except for the trimmer parts, and repaired the wires that broke off while moving it around, and soldered up the back. Everything, including a pair of is it NPN transistors, and this gets screwed back in place. So I also flooded these 2 pots with some deoxit, hoping to clean the tracks and so that we have no problems with those meter adjustments, hopefully. And while this is out, just taking a toothbrush and a paintbrush and just cleaning off dust inside there. Nothing too intense, but you know, a couple of little dust spots and cobwebs in there, and then I screw this back in place. Okay, so having done the meter boards, I am moving on to the input board, which is the main audio circuit, I suppose. And again, I think I'm pretty much replacing all of these parts. The capacitors are essential to replace. The transistors, these are not the original transistors, these were replaced. And I guess I'm just volunteering to put in new ones now. And again, most of these resistors measure out of spec, so they're getting swapped out. And the only thing really staying is a couple of ceramic capacitors, and that's it. So quite a bit of work, but let's dig in. Okay, so all those parts are off, and I've taken some alcohol and cleaned the backside and removed all the flux and so on, and I'm ready to put my new parts on. Okay, so in this session I have achieved 2 things. This input board is done, all the parts stuffed in, being very careful to observe polarity on capacitors and the arrangement of the transistor legs. Next thing I did was I replaced the old 2-prong power cable with a 3-prong and wired it up correctly. The green to chassis ground, the hot wire to the circuit breaker and power switch circuit, And the neutral is the one that goes to these two parts. There's two of these, and these mount at the bottom of the power output heat sinks. And when these get to a certain temperature, they'll open and they'll shut off. So that's wired to the neutral line and would cut off the main power transformer. Okay, so that's it. The next last part is this giant mess, which is the two output boards and the 4 heat sinks that need to get the transistors mounted. The reason I'm delaying with this is that I ordered all new fastener machine screws to mount up all of these pieces because the old ones are so rusty. And I'm just waiting on those to arrive. Then I have to tackle this whole section. But here is all done. Okay, so I'm tackling one of the last phases, which is to straighten out the 2 power output boards and set up the heat sinks and the output transistors. Now this is a real pain. I'll tell you why. Because first of all, I changed all the resistors on the transistor sockets, and a lot of wires were busted off because they're so corroded and been bent up so many times. So I spent a lot of time just trimming off a few of the original wires and re-establishing the ends that I could put solder on. Okay, but wires keep snapping all the time. So anyway, I've assembled the heat sinks. I had to put the transistors on. This is the first time I've ever done this. I'm normally a tube amp guy. I don't know about this stuff. So I'm putting on each one with a bit of white thermal compound. Of course, I put a little too much there. And I'm very careful. There's a little thin mica spacer in between the transistor and the heatsink. What else? Just trying to get everything lined up without breaking more wires. It's been a real pain. Okay, I'm done the external phase, which is the heat sinks and transistors. This was such a pain. I made every mistake possible, I have to admit. I even went as bad as mixing up transistors. Like on these, all the top large transistors are the same, but the smaller ones, the TO66 below, this and this are the same, and this are the same, but they are different to each other. I mixed up these two, so I just keep making every mistake. Anyway, I've got through most of it here, and I will shift over to the power boards on the inside. One thing of concern is that each of these transistors is mounted onto the heatsink with a thin insulating layer between them, and that either side of that layer is where you see this white thermal compound. And I'm just going to check now to make sure that none of these metal casings are actually conducting to the heatsink, because that would be a flaw in my mounting or failure in the insulators. So I have to check to make sure this and this are not in contact. And I just check the casings to make sure nothing is shorted. And this is a success. I have insulated them properly, and none of them have grounded off on the casing, so we can move ahead to the next phase. Okay, so I've managed to wire up the first board. I put all the loose wires onto their contacts, which are mostly these little turrets. Again, some people say that these turrets should be removed. I kind of agree now, because it's really hard to poke the wire back down in there without having 3 hands. And it would have been easier if they weren't there and it went straight into the board. But they were good as indicators to show where the wires are supposed to go. Make things look a little easier. So anyway, I have to neaten up those wires if I can, but I'm so careful not to break them again. It's so hard to redo the wire onto any of the joints. So that's the first power board back in place. You're up next. Alright folks, as far as this lower chassis is concerned, I think I'm done, or almost done. I've mounted up all these power boards, both of these power boards, all the resistors are in, all the parts have been replaced. I've put back this little shielding thing here. I've mounted up everything with I got some new fasteners, like these nice hex head fasteners, which are the original style. I believe I've gotten all the output transistors and the heatsink configurations correct. Most of these parts you see here are new. And I'm going to go over the wiring again and again, which I have been doing. Like I'll carefully triple check all of the input wiring, the power supply wiring, and the output board wiring concerns me most because there's just so much going in and out of these boards. This stuff I checked out when I first got it. The meter range seems fine. All the other stuff up there seems fine. Right, so the next thing is going to be bravely, well, double checking everything and then starting to fire it up for the first time. Well, that's it. I've just gone bust. I tried to turn this on. The circuit breaker here started blowing, and I kept trying to figure out what is up. Started remeasuring the power transformer wires, which I think I measured pretty well at the first early part of the project. And what I can figure out now is that this winding here has some sort of break in the winding between the center tap on one of the outer ones and the broken wire, which is giving a very high resistance to the rest of it, is shorted, so the primary. So that is some kind of disaster going on in that power transformer. So for now I am bust. Thank you.